Hello, my name is Rye Williams. I'm a welder from Victoria, British Columbia, Canada, and I'm going to share with you an idea I have that potentially could be the most important scientific discovery in the history of mankind. Okay, it all starts with a fellow named Einstein. Einstein had a theory of relativity, and one of the main components of that theory is the fact that no matter can travel the speed of light. 6 years ago, I asked myself one question. What if we got that completely backwards? What if all matter was traveling the speed of light, and all that we were calculating when we calculate the speed of light is the velocity of the universe? Okay, with that in my mind, I couldn't let it go. I didn't have any scientific background or training, so I started doing research. I ended up writing a book about it, Universal Shockwave Model, and I'll try to describe what this model looks like. Apparently it's pretty simple. Imagine 13.5 billion years ago, there was a massive bang, a big bang, and all matter was ejected out from this big bang on a massive shockwave. So I believe our entire universe is that thin shockwave, and all the matter contained on it, let's call the shockwave a gravitational wave. All of the matter is interacting with this shockwave as it coasts out from a single point in our distance past at the speed of light. Okay, sounds pretty weird, pretty crazy, but here's some of the supporting evidence. Number one has to do with the size of the universe compared to its age. Okay, so we believe the age of the universe is about 13.8 billion years. We also believe that the size is 91 billion light years across. Well, how in 13.8 billion years can something grow 91 billion light years across? Well, turns out it's pretty simple. Imagine, let's look at the circumference of a circle. Okay, and let's put as our radius the age of the universe, 13.8. What does that work out to be as a circumference? It's about 86.5 billion light years across. So 91, not quite 91, but pretty close. And maybe it was a little bit faster during the first moments of the Big Bang. Makes sense. Next major supporting evidence is to do with the theory of relativity itself. One of the main components is that no matter how fast you are moving in this universe, you will always record the speed of light as the same speed. So if we have two cars, let's call it car A and car B, and they're running straight head on to each other at 50,000 kilometers an hour, and car A turns on its headlight, and car B records how fast that light was going, they're going to record it at about 300 million meters per second. Likewise, if those two same cars are driving away from each other at 50,000 kilometers an hour, and car A looks over his shoulder and shines a light, car B is going to record that speed as the speed of light, roughly 300 million meters per second. Well, really, at the end of the day, it doesn't matter how fast those cars are burning around on the membrane. It matters about how fast that membrane is actually moving. So you're not recording anything except the velocity of the universe. And it doesn't matter how fast you're moving on this membrane, it's the speed that the membrane is moving that we're recording when we record the speed of light. Okay, within this model, a really easy way to explain it would be blowing up a balloon. Imagine the universe as being the skin of that balloon. The rubber component of that balloon is the universe, is this massive shock wave, gravitational wave, that's ejecting out at the speed of light. So we can describe things like black holes within this membrane. We can describe orbiting. We can describe the way that matter will create dents in this membrane, and along with heat, which repels and surface tension of this membrane that draws. We can describe gravity. We can describe how planets circle each other. We can describe pretty much everything there is known about the universe within this model. Okay, so now it's your job to help me support this. Okay, I'm not a scientist, but I think it's an amazing idea that has the potential of being, like I said, the most important discovery in humankind, because it describes potentially what is actually happening in this universe and what we are witnessing. Okay, so if anybody would like to help me, let's split a Nobel Prize. That'd be pretty sweet, right? Okay, thank you very much, and hopefully this gets your mind going. Thanks. Bye-bye.